Ink and foils. That's pretty much all German company Belectric OPV needs for its wafer-thin, plastic-based, organic photovoltaic modules. Hermann Isser is hoping to corner the market with these organic solar cells. So far, his company's biggest success has been in Africa. The lightweight, flexible modules have been integrated into the roof of the new African Union Conference Center in Addis Ababa in Ethiopia. They provide the electricity for the building's lighting.
This is a trailblazing project for the region. It's been very exciting for people here to work with cutting-edge technology, the same technology that's used in the West, and to see that a project that's really unprecedented anywhere in the world is being implemented here, in their country, on their continent.
Conventional solar cells are made of bulky silicon. Organic solar cells are simply printed, using a kind of ink made of special carbon compounds. David Müller of German chemicals maker Merck explains.
This ink contains materials that absorb the light in the organic solar cell and convert it into electricity. The finished module is a relatively complex multi-layer construction that determines the form, flexibility, and transparency.
The organic photovoltaic modules are more environmentally friendly than silicon-based solar cells. They use less material and don't require any rare earth metals. Their production is also less energy intensive.
We don't need to purify the material and we don't need high temperatures. There's no blast furnace or reactor involved. It's just simple printing technology.
These solar trees were showcased at the 2015 Expo in Milan. These days, organic solar cells come in all shapes and sizes, which is why they also appeal to architects and designers. However, for the time being, they have a lower energy yield than standard solar cells. That's why they still haven't cornered the market. Researchers in this physics laboratory at the University of Würzburg are testing new polymers. Their aim is to make the solar cells more efficient. Physicist Vladimir Diakonov is an expert on photovoltaics.
You can see here real organic solar cells made of different polymers that give different colors but also different efficiencies. And they are very nice and very attractive for future application in buildings. For example, architects, they like different colors. They don't want to stick on blue like silicon solar cell, but they want to have green and yellow. And so that's actually probably the future.
Today, chlorine is still often used in the industrial production process. It can damage the skin and the airways. Diakonov and his team are developing a cleaner alternative.
We have selected a set of interesting candidates, the so-called green solvent, and combination of this green solvent that do not contain chlorine. 5-6 interesting solvent that can be used to dissolve these organic polymers and small molecules to make a solar cell.
The technology is still in its infancy. The idea is to integrate it into building facades, where it will produce electricity exactly where it's needed. The printable organic solar cells are an affordable technology that could easily be adopted in Africa.
The investment is relatively low compared to traditional silicon-based technologies. They require a lot of funding to set up production and see a monetary return later on.
The long-term vision foresees organic solar cells made in Africa, lining the facades of high-rises to provide electricity for entire cities all over the continent.